Okay, moving on to formatting output. If we would like to calculate the total cost of a meal, maybe we declare a double and say total underscore cost. We just declare this and we're about to assign that value to some stuff. We can use floats. Floats are called single precision. This is called double precision. Doubles have twice the, or given twice the amount of memory on a computer as a float compared to a float. Nowadays, we're not usually concerned about memory, so we use doubles. You will in certain fields, if you go into certain fields, want to occasionally use floats instead of doubles, possibly. Okay, so base meal cost equal $14.99. And then we want to calculate the tip. And tip is equal to base meal cost. I just hit tab to auto-complete the variable name. This is very convenient to do because what if I accidentally capitalize the M? All of a sudden this variable name is undefined because C++ is case sensitive. So again, it is useful. It saves your fingers from arthritis to hit tab here, or you can double click and take that. So a tip, a reasonable tip, depending on service in the United States, customs are is to multiply the base meal cost by 20%. And now we could calculate total cost is equal to base meal cost plus tip. We've all pretty much all of us have done this before. And now we'd like to print this value. Maybe we want to include some dollar symbols as well. And give it some text because it's not nice to just see numbers on a screen as output. It's nice to have some context. So total meal cost is colon dollar some dollar amount. So the US dollar system, the USD, is typically displaying to the nearest cent, the nearest hundredth of a dollar. So this is a dollar, of course. Most people don't need to hear this, but I'm pointing this out for a reason because our output is going to look a little bit strange. So $17.98 and 8/10 of a cent, 8/10 of a cent. So that looks strange. And there's a way that we can, it looks strange to Americans. So there's a way that we can alter this, and it involves the use of something called set precision. So set precision, it does what it sounds like. It's a function. It takes an argument. Only there's an error here. Set precision is undefined, and it's undefined right now because all we have pound included is IOStream. Remember that there was quite a lot in IOStream, quite a few lines of code. But evidently there is no function called set precision in there, and it is in pound. It's in the header file. You see this H symbol. Again, there's no .h at the end, I believe, because this is a C++ file. C files by convention. C is the precursor language to C++. C files generally include that header .h at the end of the file name. And the angle brackets here, in case we're curious about this, the angle brackets, if you notice, once I type in angle bracket, there are many header files that are in that. I'm not using double quotes like I used a few videos ago. The double quotes by default puts me in this file path. That 64-bit, that comes from right here. Debug, that also comes from right here. These are called the configuration settings. Like what operating system are you going to deploy this executable on? if we open folder in File Explorer and we navigate to, I think, this directory, we go to debug, there is a file called with the extension exe, and you see the type of the file is an application file. So if we were to want to, right click and copy that executable and maybe send it to one of your friends and give them a virus or something silly like that. Not give them a virus, but if you were to want to copy that executable file, you would want to make sure that is it 32-bit, which is x86, or 64-bit. The debug versus release mode will generally execute faster. Anywho, these angle brackets mean that we are searching in certain directories that are on our computer, like the include folder is usually what it's called in C++. So if we go to another of these, this is the file paths are complicated here. This Windows kits, those are built into the operating system, I believe. But the angle brackets, to put it briefly, they look at a particular directory, a particular file path, whereas the double quotes look in our current directory, the directory in which this CPP file is located. Okay. Set precision is, let's see, not yet defined. And if we hover and say show potential fixes, we see pound include IO manipulation, IO manip, and I double clicked and it auto generated that for me. So that's nice. We do need to say standard set precision, or we could just say up top using standard set precision. And I think, interestingly, no parentheses is necessary there. So if we say we want this dollar amount displayed, the total meal cost displayed to the nearest 2 decimal places. So can we say this? Set precision 2, it seems like a reasonable thing to do. Except we still see this strange value. And if we hover with the mouse after we ran, we see this warning, return value ignored. So the syntax here is actually we need to say cout set precision 2. And now we'll see something closer. We'll see a change, $18. So this is set precision 2 displays 2 digits. If we increase this price to be a really expensive meal like this, we see 1.7, so 2 digits raised to the multiplied by 10 to the power of 7. That's what this E notation means. So $17 million meal. But to see 2 digits after the decimal point, we actually have to use an additional thing called fixed. And let's see, if we hover with the mouse here, standard fixed, this thing called fixed that comes from the standard namespace in the file IO manipulation. If we right click here and we say go to document, then Control F, fixed. Interestingly, fixed is not found in there. Let's see, set precision. Yeah, there's set precision, and if we right click here, then we can go to the definition of that, which is somewhere in this file. This code is getting complicated, but let's run this program and see what happens. There we go. We see some output that we would like to see. You could set precision to very high precision, like 6, which doesn't make sense for the US dollar system, but it has certain applications. We remove the fixed. The fixed means a fixed number of digits after the decimal place, in this case. 17.988. That's a little bit surprising. Set precision 4. 1799. Let's see. So what is, let's use an alternative calculator here that has different settings from C++. So the 14.99 times 0.2, 14.99 times 0.2 is 2.998. And if we were to do this by hand, we would see that this is the value with infinite precision, so to speak. There's an infinite number of zeros after this. This is exactly the result. There's no rounding error. There's no truncation. So let's say plus 14.99, and it's exactly 17.988. So if we say set precision to 10 here, that's kind of an interesting thing to see. 17.988. I suppose C++ is saying there are a bunch of zeros out here and they're not worth displaying. This does get to the subject of, it's somewhat related to the subject of what I call false precision. We wanted to be really careful about this. This is a science engineering tangent. So if we were to declare a variable named pi and say that it's 3.14159, in fact, pi is a constant, which is the opposite of a variable. A variable, by definition, is something that can change. Let's just print pi here instead. So if I have only initialized this value with this amount of precision to the fifth decimal place, 1, 2, 3, 4, 5, and I say set precision 10, what am I going to see here? 3.14159. Okay. But I think if we were also to specify fixed, yeah, I may have been mistaken a few minutes ago about my assertion of C++ just not wanting to display zeros. It was a bit of a silly thing to say. Yeah, then we'll see these zeros here. So this is an example of what I would call false precision. We only know pi to 5 decimal places, but a computer in this case can just add a bunch of zeros that in fact are not there. We don't know if these are 0, 0, 0. This will, what I'm saying now will resonate with people who have some science and engineering background, and you know about a quantity called uncertainty in measurement. There's uncertainty in all measurements, and there's also something called Heisenberg uncertainty principle, which is somewhat related to this. That's a subject of quantum mechanics, or one of the subjects in quantum mechanics. Okay, I'm just going to copy some code here. This gets to something called set width. So if we want to make a table, let's see. Set width. So set the width of a column. And let me just say using standard these things, so that I'm not having to type them as much. Okay, so we could now delete what I was typing earlier, and it should run okay. So you can imagine what I might be doing here. First name, last name, height, and we have some people. Jane Doe, 64 inches, Seth Norman, 69 inches, and we run this program, and we see this, a fairly nicely formatted table. So left means left align, it seems. Set width makes space for 16 characters in front of the after and including Seth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Maybe we change this to 10 instead and see what happens. Okay, the output looks a little silly now because the 69 is hopped over here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is very briefly how this works. I don't often find myself using set width, but set width does what it sounds like. It sets the width of a column in a table. That's the most common use case that I've encountered. Okay. So getLine is a new function that we're going to talk about. GetLine can get an entire line of text. It's not defined right now. If I hit Alt Enter, we can see some suggestions, which in this case, I'm not going to take either of these suggestions. GetLine is related to strings generally. So if I pound include string, and I say, let me just say, in the interest of removing some of this, all these lines of code here, I'm just going to say using namespace standard. So I'm no longer going to have to say standard CF. Again, this is not considered good coding habit, but for now, I'm just going to take it. Okay, so now getLine, the error is not the same. It just says I need to pass in arguments here. So let's do that. So enter a line of text. A line of text could also be thought of as a string of characters, like this string. In fact, if I hover there, that is not strictly speaking, this is not a string in C++. It's a character array, an array of characters. There are differences between those. Okay, enter a line of text, and that's our prompt. And we would like to read that, maybe using cin and store it somewhere. Store it in a variable, and it'll be a string variable in this case. Excuse me, not name, but line of text. Remember, this is called camel case. The case I've been using earlier is called snake case, because there's this little underscore that looks kind of like a snake. Okay, so we attempt to read in the line of text and then echo back at them. We'll use getLine in a minute here. I did have to pound include string. String is defined. If we right click, go to document, there's a function called getLine in there. And we won't worry about the details of it right now, of how it's defined. Okay. See how you entered line of text. And we'll just 1, 2, 3, 4, 5, 6, 7, 8, 9, that. And it only captured that cin operator, or the cin object, along with this operator, which is called the if you want to put it in a fancy way, it's called the stream extraction operator. Maybe we just call it the input operator. But it only captured, this thing only works up until the first space. And that may seem like a silly rule, but it is what it is. There are reasons for it that I'm not going to get into, because I haven't looked into them in great detail. Okay, so instead of saying cin, let's test this function called getLine. And if it works like we expect it to, I mean, the name of the function is getLine, so it should hopefully get a line of text. The syntax is a little bit funny. We actually have to type cin. That character N is what this means. as in read characters in. Let me say cn equal character in. C out means put characters out to a terminal or a screen. And the second argument is going to be the string variable that we declared. Okay, so there's no error evidently. Let's see if this works. There's no syntax error. There may be a logic error. Okay, and we got all of that up until I pressed enter. And if you want to get multiple lines of text, we'll handle multiple lines of text maybe when we get to loops and arrays. Okay, I talk a bit about debugging with cout. So suppose that you have you want to perform a Fahrenheit to Celsius calculation conversion. I just copied that. I copied that from a text, the PDF and Adobe Acrobat software, the Adobe Acrobat software PDF viewer. And you'll notice that minus symbol, there's some problem here. It says expected a closing parentheses, which is not a very helpful error message in this. And this is getting to the point of, like, if I backspace and press minus, it looks pretty much identical, but there's a subtle thing going on here. It's how different text editors encode different characters. So I copied this from Adobe Acrobat. So the way that it's just a very interesting thing to be aware of, and it can be quite tricky. Smart quotes are another example of that. Smart quotes, curve. Yeah, you can look it up. So I say here, test the water boiling point, which is 212 in Fahrenheit. Now, this is the calculation that converts Fahrenheit to Celsius, 5/9 times Fahrenheit minus 32. So let's see what we see here. We know, most of us know that the Celsius equivalent freezing point, the freezing point in Celsius is 0 degrees. The boiling point of water is what we're talking about. We're not talking about anything else. If for those who have some affinity for chemistry, you might. Okay. That might give you pause, the fact that I'm not clarifying what substance I'm talking about. Okay, so let's see. So Celsius freezing point of water is 0 and Celsius boiling point is, okay, so the first line of output makes sense. Second line does not, because the boiling point of water is definitely not 0 degrees Celsius. It's 100 degrees Celsius, and you can look that up if you're not familiar with that. So what happened here? Well, this gets to the point of debugging with cout. So we could, this is a somewhat complicated expression. We could actually break it into pieces. And I'm going to go ahead and zero in on the problem here. And that is this. So this, if I hover, it says, let's see, int 5, int 9. So this is actually integer division in this case, because both of the operands, 5 and 9, I'm saying the word operands. And those operands are 5 and 9. There's another vocabulary word here called operator. An operator is the symbol /, which is integer division. Okay, so if we run this, we're going to see 0. This 0 corresponds to this right here. So 0 times anything is 0, and that's why we were seeing that the boiling point is 0. So I would call it debugging with cout. Like if you ever obtain an output in a program that doesn't make sense to you. You might break your expression into pieces, like this mathematical equation or expression. You might break it into pieces and take a look at what's going on there. So one way to fix this is to sort of convert this to a double type. And now if you have one double and one int, one integer, then that will get interpreted as integer division. Now it says the boiling point is 100, which makes sense. Maybe we want a colon and a space there to make the output look a little nicer. And there we go. If you want to make degrees, that's kind of a good thing to possibly look into, degrees Celsius. If we bring up the internet and say degree symbol, this might not work. It's a nice thing to see though, possibly. Copy that from some website. Who knows how it will get interpreted, degrees Celsius. Who knows how it'll get interpreted by C++. Maybe it'll be correct on the terminal. And it prints some funny character, so we want to be careful about that. This has to do with something called the character map, and I'll just leave it at that.